Namaskar, welcome back. So, in last lecture, we had detailed discussion on the magnitude part, and then this was the last slide where we were talking about that how the moment magnitude scale came into usage, and this is this scale which has been used worldwide to measure moderate to large magnitude earthquakes. Now, moving further about the magnitude, usually that what we have discussed is that it is a measure of the size of an earthquake. So, if for example, the magnitude increases by 1, okay, and this part I have briefly mentioned way back in one of the lectures, that the energy released is much higher. Okay. So, if you increase the magnitude by 1, the energy is about 31 to 32 times larger, okay, than the 1 magnitude. So, usually we should not say that okay, fine, this 1 magnitude earthquake or 1 to 2 magnitude earthquake. There is a lot of difference between the 1 magnitude and magnitude 2 and so on. So, if it increases again by 2, then the energy which will be released will be around 900 to 960 times more. Okay. So, for example, if you take and compare the magnitude and the amount of energy released by those type of earthquakes or those magnitude of earthquakes which has been given here, it is a multiplication factor of almost 32. Okay. And if you recall the Hiroshima atomic bomb which was been dropped during the World War, that was almost like 5.5 magnitude only. Okay. Now, seismic energy, there are a few studies which helps us in understanding that what will be the amount of energy which will be released, and one can also talk about that what will be the number of magnitudes we will require to suffice a particular magnitude earthquake. Okay. So, the amount of energy released is related to the Richter scale, and it is given by the equation log E is equal to 11.8 plus 1.5 m. M is your magnitude. Okay. So, if you put in magnitude here, you will be able to get the energy released. So, mostly many scientists they use this equation to understand that how many earthquakes of a particular magnitude will be required to suffice. For example, if you require 5, how many 5 magnitude earthquakes would be required to suffice the energy released by earthquake of magnitude 6. Okay, that can be done. Okay. So, this is a chart which was been given by USGS, which shows that the largest earthquake, what was the energy which was been released. So, on the left hand side, the scale shows your magnitude, and right hand side is your the amount of energy which has been released, in which is equivalent to kg of explosives, okay, kilograms of explosives. And so, the largest so far which has been listed is your 1960 Chilean earthquake, 9.5 magnitude, and there is an in sort of an overlap between the 2004 and 1964. 2004 is your Sumatra Andaman earthquake, and Alaskan earthquake of 1964 is pretty close to that in terms of the magnitude, but as per our understanding, the Sumatra Andaman earthquake of 2004 is very close to the second largest earthquake so far recorded on this planet. Okay. So, you have multiple earthquakes which are been listed here as compared to your magnitude. Okay. Now, there is another based on the empirical relations, the curves have been generated. Again, this curves shows that what is the relationship between the magnitude and the earthquake and the fault offset. Okay. So, different type of faults, we will come to that: strike slip fault, normal fault, and reverse faults, which are been given by different color of lines. Okay. So, on the left hand side you have moment magnitude versus the displacement. Again, this is a logarithmic scale you have, and that shows that at what will be the amount of displacement which is expected, and probably it will be on that fault if a particular magnitude earthquake has been triggered or hosted on that fault. Okay. And that fault type is also been given. So, that has been shown by different lines. Now, very interesting thing which is on the, again you have the log scale on the x axis of which shows the surface rupture length. Okay. Now, in most of the earthquakes it is important to understand that what was the length of the rupture. So, based on the historical data, people have carried out the paleoseismic studies and they have tried to constrain the length of the rupture, plus based on the recent earthquakes which were been measured by the instruments. Okay. So, for example, 7.5 magnitude earthquake will have a surface rupture length on, that is on the on surface, that is your length on surface, will say it will be around 160 kilometers. Okay. So, if you have 160 kilometers of rupture, then you can say that the magnitude would be around MW, again it will be around 7.5. Okay. So, very short, but magnitude is quite good enough, at least for the Indian side, to create a huge damage. Okay. And in case of 1960 earthquake, the magnitude which was around 9 point, not around, but it was 9.5 MW. So, that resulted into almost a rupture of 1000 kilometers. And this was again, as we were talking about, this was subduction zone earthquake. Okay. And then 9.3. So, maybe we can say that, okay, fine, this could be the length of the rupture if you have this magnitude, but 9.3 Sumatra Andaman earthquake was having bit larger. It went up to like 1300 kilometers, and that was because of the triggered stress on the nearby segment, which also got ruptured. Okay. And that's how we got with 9.3 we got the rupture length of 1300 kilometers. And if you expect, till date we haven't, okay, but if you expect an earthquake of magnitude 10, okay, theoretically maximum earthquake, okay, till date, as I said, it is not, we have not experienced, and we pray that we should not. Okay. Now, in that case, the rupture would be almost like the circumference of the earth, okay, which is equal to around 40,000 kilometers. This will be the rupture which is expected as per this graph. Okay. So, it is going to be a massive disaster on this planet. Now, again the energy release, if you have the comparison between different earthquakes, a Richter magnitude difference of like 0.2 is around 2 times the energy, 0.4 is around 4 times energy, and so on. Okay. So, if you have 2 is greater than like 1000 times the energy, okay, so almost like 32 into 32, and then same goes with the 4, you have a pretty large amount of energy which will be released. Okay. Now, if you take an example, for example, like the each whole number increases in magnitude corresponds to an increase in energy release of approximately 32 times. Okay. So, for example, 32 magnitude 6 earthquakes. Okay. That means 6 magnitude earthquake, 32 you will require, okay, to equal the total energy released by one single 7 magnitude earthquake. Now, this statement is quite important, because sometimes what happens that we feel that okay, there are couple of earthquakes of 6 to 6.5 magnitude in the region, okay, and then we say that okay, fine, there are many earthquakes, then we have the energy has been released, okay, but we need to understand that what is the potential of that area to trigger the earthquake in terms of the magnitude. Okay. So, for Himalayas, the Himalaya has potential to trigger earthquakes which ranges from 7.5, okay, we can say greater than equal to, or we can say less than equal to 8 to 8.5. Okay. So, this is a range which we usually look at as a potential of the Himalayas. Okay. So, potential to host, okay, we can say earthquakes of magnitude 7.5 to above or equal to that, or less than 8.5, okay, or equal to 8.5. So, you can calculate that how many 7 magnitude earthquakes would be required to suffice this energy which is available in the Himalayan zone, okay, and similarly goes for others, okay, because in the central portion of the Himalayas, which we say central Himalaya, it's part of Nepal also it covers. Now, that is Kumaon Garhwal region. We had couple of one or two, maybe, I think 2 earthquakes of 6 to 6.5 magnitude, and then people started talking about that, oh, this area will not have earthquakes in near future and all that, okay, but it is not so. You need almost like 32 earthquakes of 6 magnitude or little less of 6.5 to suffice the energy of 7 magnitude earthquake, okay. And similarly, more than 1,000 earthquakes of magnitude 6 would release energy equal to 8 magnitude earthquakes, okay. So, then you need almost 1,000 6 magnitude earthquakes, okay, for sufficing the energy of MW8. So, as I told that Himalaya is having potential to host earthquakes of magnitude above or equal to 7.5 and less than 8 or equal to 8.5. Okay. So, that means that you may require thousands of MW6 earthquakes to suffice that energy. Now, coming to another part, which is the again and most important one, because this has a direct relation with the damage pattern and evaluation of your seismic hazard for any region. Okay. So, acceleration is normally designated as some proportion of the acceleration of gravity g. Okay. So, 1 g is the acceleration felt by a freely falling object. Most earthquake acceleration are less than 1 g and few with more, okay. Because if you have 1 g, it is quite dangerous. Okay. An increase in magnitude about 6 does not cause much strong shaking, rather it increases the area and total time of shaking. So, this time of shaking also plays an important role. Okay. Now, for example, earthquake of magnitude 5 generally lasts for, this is based on the recorded earthquakes, that what will be the duration of your seismic shaking. Okay. So, 5 magnitude earthquake lasts only for 2 to 5 seconds. Okay. And mostly this type of earthquakes of magnitude 5 are nowadays experience nearby Delhi. Okay. You can say New Delhi. There are many, okay, and this type of magnitude or this type of magnitude of 5 and less than 5 are experienced in Himalayas every day, okay. But they will last for this is I'm talking about the magnitude, okay, and this is your, so it will last for 2 to 5 seconds, nothing will happen, okay. But if you have 7 magnitude earthquakes in any area, then it will last for almost 20 to 30 seconds, and of 8 it will be around 50 seconds, okay. And this 50 second is quite good pretty time that can create a huge damage in the area, okay. Now there is a 7.9 magnitude earthquake of 1906. San Francisco had an ground acceleration not much, it did not even reach 1, okay. It was just half, 0.5 to 0.55 G, okay, but resulted into massive damage in the region. So ground acceleration and shaking time. A magnitude 6 earthquake shaking lasts for only 10 to 15 seconds. Now this will provide only a shorter time to evacuate. A magnitude 7 or larger than 7 magnitude provides more time because it will have more time shaking, okay. But evacuation is harder to do because the ground acceleration may approach 1 G. The longer shaking lasts, the more damage occurs. Structure weakened or cracked in first few seconds, okay, of an earthquake are commonly destroyed with continued shaking, okay. So this line is important, okay. The longer shaking lasts, more damage will occur, because there is almost no time to evacuate, because the ground acceleration is much higher as compared to 6 magnitude earthquake, okay. And this has happened in many of the recent earthquakes, that people ran out and the deaths were related to the falling debris from surroundings, okay. So it is generally best to duck under the sturdy desk, lie next to the very steady piece of furniture for protection, okay. So this is the part of that what you do at the time of the strong ground shaking, okay. So one of the effects of earthquake of 1964 Niigata, and that was 7.6 magnitude, and 1999 Izmit, Turkey earthquake of 7.6, okay. Recently also we had an earthquake in Turkey, okay, which was quite damaging on northern Anatolian or eastern Anatolian fault, if I am not wrong, okay. So result is, as on the left hand side the photograph shows the massive liquefaction, toppling of the buildings because of the strong ground shaking, and also on the other side you see is your Izmit earthquake, which resulted in, and similar damage was been also observed in Kutch during 2001 Bhuj earthquake. Now here is the some comparison which has been done based on the intensity values and description and average peak acceleration, okay. So what you will expect and what will be the intensity plus which type of effect you will observe during that. So for example, if you start with the intensity 4, then during day felt indoor may by it will be felt by many people who are indoor, okay, and very few by who are outdoor. And you will also notice the shaking of automobiles like cars and all that. So, in this case the acceleration is much less, okay. So, 0.015 to 0.02 g. So, comparison is being given and what will happen. So, for example 7, then you will have around 0.1 g to 0.1.5 g. Further, if you are having intensity of 8, which could be comparable with your magnitude greater than or equal to 6, then again you have 0.25 to 3.3 g. Okay. And this was the case which we were talking about, the 1906 San Francisco earthquake. And since the magnitude of the Bhuj earthquake was also very close to this, okay, which was MW 7.6, okay, the acceleration which would have been there at that time was around 0.5 to 0.55 g. Okay. But if you are having a massive earthquake, then the ground acceleration may go above 1 g, okay, which gets into your intensity 11 and 12. Okay. So, masonry structures, I mean standing bridges destroyed, broad fissures will be developed and all that, and total damage will be on your 12 intensity, and that will result definitely the magnitude if you talk about, then it will be greater than 7.5 or around 8 magnitude. Okay. And in this case you will see that the objects are most likely to be thrown into the air. Okay. So, that will be the situation here. Now, just to have the information about the first seismological observatory in India. Okay. So, as you see on this figure, we have number of earthquakes which have been mapped and plotted, okay, measured by the instruments, which also which are you can see the legend here. It goes from less than 3 magnitude micro earthquakes to moderate and large magnitude earthquakes. Now, this was the first instrumental earthquake observation in India date back to 1898, okay, and that was even after 1897 Shillong earthquake. So, with the first seismological observatory of country established at Alipur, and that is Kolkata, now Kolkata, okay, on 1st December 1989, after the great Shillong earthquake of 12th June 1987. So, this part of information I thought that I should share with you, and that you should keep in your memories. Okay. So, first observatory of India. So, instrumentation started recording the earthquakes in 1989. So, with this I will stop here and we will continue with having discussion on more topics in the next coming lecture. Thank you so much. Namaskar.